Hello everyone. Today we will discuss about gamma function and beta function. Let us start. So our first topic is gamma function. In this video I will explain you about gamma function, and in my next video I will explain about beta function. We will discuss some topics, some results and some examples of gamma function today. So let us start. Gamma functions. Gamma function is denoted by factorial n is equals to 0 to infinity e minus x n minus 1 dx. Important results. So our first result is factorial 1 is equals to 1. We will prove it. Let us see. Factorial 1 is equals to, so in this is our representation. Gamma means gamma function is denoted by like this. So what we will do, we will put n equals to 1 in this. What we will get? So what we will get, 1 minus 1 is equals to 0. So 0 to infinity e minus x x की power 0 dx. As you know, x की power 0 is 1. So we will get like this. And if we integrate it, minus sign will come outside. So our result will be 1. I hope first result is clear. Now second result. This result is very important. Let's see. What we have to prove? We will prove factorial 1 upon 2 equals to pi, root pi. So in this, what we will do? In same this result, we will put n is equals to 1 by 2. N is equals to 1 by 2. So 1 by 2 minus 1 will be minus 1. I hope this is clear. So now next step is, we will put x is equals to t square. In place of x we are writing t square. So e minus x, what will become here? Minus t square. X minus 1 upon 2 will become t की power 1 upon 2. And if we differentiate it, see, x equals to t square. If we differentiate it, we will get dx is equals to 2t dt. So we are writing it like this. In place of dx we are writing 2t dt. Clear? And t minus 1 will, we can write it 1 upon t. So t and t will cancel, 2 will come outside. We will get this expression. And this is equals to pi. This is equals to pi. Now 2 will come here, this side, and it will become 0 to infinity e minus x square dx is equals to pi by 2. As we know, 1 upon 2 equals to 0.5. Now we can say that root pi equals to 1.772. I hope this is clear. This result is very important. Now let us start second one. Second, reduction formula. Reduction formula is also important. What we'll get in reduction formula, what we have to prove? We have to prove that factorial n plus 1 is equals to n factorial n. As we know, factorial n equals to 0 to infinity e minus x n minus 1 dx. So if n is replaced by n plus 1, see, this is factorial n. If in place of n we are writing n plus 1, what we will get? 0 to infinity e minus x n plus 1 minus 1. So 1 and 1 will cancel. We will get e की power n dx. Okay. Now we can write it like this. Now what is this? We have done the integration. E, as you know, you must be knowing isolate. We have used here 0 to infinity e minus x की power n dx is equals to, we are integrating x की power n as it is, e minus x we are integrating, minus will come outside, is 0 to infinity first, plus now this time we are integrating x की power n, so n will be outside and power will be negative, e minus x as it is, x n minus 1. I hope this step is clear. This is basic maths only, 11th 12th class maths we have used here. So this term will be 0. This term will be 0. If we are putting 0 and infinity, we will get 0 and we will get this. So n as it is, and this expression as we have studied earlier, this is factorial n. So in place of this we can write factorial n. So what we will get, factorial n plus 1 equals to n factorial n. Now third result, 0 to infinity e minus kx xn minus 1 dx equals to factorial n upon में kn. Same result we have done more so many times. Okay, now in this time in place of t we are writing t is equals to kx. So dt will be k dx. This step is clear. Next, so in place of t we are writing kx and k will come outside. What we will get, 0 to infinity e minus x xn minus 1 dx. So this term as it is and kn will go in denominator. That's it. This was the proof. I think this is clear to you. It was very simple. Now next we will discuss about extension of gamma function from factorial notation. Okay, now first case when n is a negative integer, when n is a positive integer. See, factorial n plus 1 is equals to n factorial. We can write n minus 1 factorial n minus 1. Okay, similarly if we can write n minus 1 n minus 2 factorial n minus 2. I hope the pattern is clear to you. Next term will be n minus 1 n minus 2 n minus 3 and factorial n minus 3. Another term will be n minus 1 n minus 2 n minus 3 n minus 4 and factorial n minus 4 will be inside. ठीक है, if we solve it, if we continue the pattern, what we will get, we will get this. And what is this? This is factorial n. This is n factorial. Okay, so from this we can say that factorial 2 is equals to 1 factorial, factorial 3 is equals to 2 factorial. I hope this is clear. Now second, when n is a positive rational number, when n is a positive rational number. In first case we have done n is a positive integer. In second case we are doing n is a positive rational number. Okay, factorial n is equals to n minus 1 n minus 2 up to a positive number in factorial function. Now let us start. Factorial n upon 2, factorial 7 upon 2 is equals to 5 by 2, 3 by 2, 1 by 2, factorial 1 by 2 will come here and we'll solve it. We will get pi. How we are getting pi? Can you tell me why we are getting pi? Please tell me in comments why we are writing pi here. Okay, please tell me in comments why we are writing pi. If you are watching the video very sincerely, you can easily tell me why we are writing pi here. Please tell me in comment section. Okay, next, factorial n upon 4. We can write it like this, and factorial n upon 4 can be obtained from the table of gamma functions. ठीक है. Now we have done, till now we have done two cases. Case 1, first case is when n is a positive integer. Case 2, when n is a positive rational number. Now third case, when n is a negative rational number. N is a negative rational number. So factorial n plus 1 equals to n factorial n. Okay, so we can write it like this. Factorial n plus 1 upon n equals to n factorial n plus 1 n plus 1. ठीक है, continue the pattern. See the pattern and continue it. What we can write next? Factorial n plus 2 n plus 1. Factorial n plus 3 n plus 1 n plus 2. Next term will be factorial n plus 4 n plus 1 n plus 2 n plus 3. Continue the pattern and you can see that what we will get. We can see the pattern. Factorial n plus k plus 1. If k is 1, suppose the k is 1, so n plus 2 n plus n plus 1 and n plus 1. Continue, means one term is more here. If we are writing 3, then terms will continue till 2. If we are writing 4, terms will continue till 3. Now here we are writing k plus 1, so terms will continue till k. If we are writing k plus 2, terms will continue till k plus 1. I think this is clear. and this term is positive. This term is positive because we have taken when n is a negative rational number. This term is positive where k is at least positive. ठीक है. If we are taking a negative factorial minus 3.4, if we are writing it like this, what we will get? We will get a positive, again positive. Factorial 2.4 is k, the value of k is greater than 2.4. Greater than 2.4 means what? K is equals to 3. I hope this is clear now. Now next, fourth case. Let's complete fourth case also. Factorial n is not defined when n is equals to 0. Factorial n is not defined when n equals to 0 or a negative integer. As we know, factorial n equals to factorial n plus k plus 1 n plus 1 till k plus n plus k. अभी हमने ये किया था. Just now we have done it. Okay. N equals to 0, minus 1, minus 2. If we will have a 0 in the denominator. We will have a 0 in the denominator. See. If, and as you know, if 0 is in denominator, then that number is not defined. You can see 0 in the denominator, it means this is not defined. In factorial minus 1 also, 0 in the denominator, it means it is not defined. So from this we can conclude that gamma function cannot be defined for 0 or any negative number. I think this is clear to you. Okay. Example number 1. If n is a positive integer, show that n is a positive integer, and we have to show that 2n factorial n plus 1 upon 2 equals to 1.3.5 2n minus 1 root pi. We have to show it. ठीक है. Factorial n plus 1 upon 2 equals to factorial n minus 1 upon 2 plus 1. Same, continuing the same pattern as we have discussed earlier. N minus 1 upon 2 factorial n minus 1 upon 2. See, we are using it. We are using this result. Okay. Again n minus 1 upon 2, n minus 1 upon 3. So factorial n minus 1 upon 3. Next term will be n minus 1 upon 2, n minus 3 upon 2, n minus 5 upon 2 factorial n minus 5 upon 2. See. If we are continuing the pattern, in the end, what will be our last term? 1 upon 2. So, what we will write in factorial? We will write 1 upon 2. So, if we solve it, what we will get? 2n minus 1 upon 2, 2n minus 3 upon 2, 2n minus 5 upon 2. And why we are writing pi here? Because factorial 1 upon 2 is pi. We have done it in this video. Earlier we have done it. Factorial 1 upon 2 is pi. So, from this, we can write 2n factorial n plus 2 is equals to 1.3.5 equals dot 2n minus 1 factorial, root pi. I hope this is clear to you. Now, this is our second example. There are 4 parts. Try these examples. You have to try these examples. I am giving you the solutions also. You can take the screenshot of it. Try these examples, and still you have any doubt, you can ask me in comment section. I will clear your doubts. In my next video, I will discuss about the beta functions. We will discuss about the beta functions. I hope this video is clear to you. Gamma functions is clear to you, and this is helpful for you. Thank you so much. For my more videos, you can subscribe my channel. You can go for my videos also. Thank you so much.